Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.
You are welcome back to the science session. We are still on conversion and conservation of energy. We are still on conversion and conservation of energy. And on Wednesday, we started calculation involving kinetic energy. We started calculation involving kinetic energy. Today, too, we are going to continue. After that, we go to energy transformation. After that, we go to energy transformation. So I want you to pay attention. And once again, I thank you for watching this channel. Now, the other day, on Wednesday, we started solving some problems concerning kinetic energy. So I told you that before you sit down to solve any question, we have to write down the formula. If the question is about kinetic energy, you have to write the formula down. So the formula is Ke is equal to half mv squared. Half mv squared. I hope you can see from the board. Half mv squared. So this is the formula for kinetic energy. This is the formula for kinetic energy. So if a question is given, you have to take your time and list down the parameters. Take your time and list down the parameters, okay, before you start solving the question. And if you are told to find the mass, you have to make m the subject from this relation. You have to make m the subject from this relation. How can you make m the subject from this relation? You just multiply the two through them. So this is the first entity, and this is the second entity. The whole of this is 1. It's like so we have half times m times v times v. It will give you half mv squared. So the whole of this is 1. So this is the first entity, and this is the second entity. So you use 2 to multiply. We are making m the subject. So 2 times kinetic energy is equal to 2 times half mv squared. Half mv squared. So here you get 2 Ke. You get 2 Ke is equal to this, or cancel this. So you have mv squared. We have mv squared. We are making m the subject. So you divide both sides by v squared. So that this v squared will cancel this v squared. So our mass is equal to 2 times kinetic energy out of velocity squared. So if you are told to find the mass, the kinetic energy will be given and the velocity will be also given. So you just list down the parameters and put in the figures. The most important thing is to recall this formula. So this one is equation 2. This one is equation 2. you can be told to find the velocity. It's the same procedure. So you just write Ke is equal to half mv square. Half mv square. The same procedure. You choose to multiply them. So 2 So here you get 2 Ke. These two will cancel these two. You have v square. We are making v square the subject. So divide both sides by m. So that this m will cancel this m. So here our v square is equal to 2 times Ke out of m. So after finding the v square, you find the square root of both sides. So we are going to solve some problem concerning the velocity. We are going to solve some problem concerning the velocity. The velocity. So let us solve our first example concerning the velocity. Concerning the velocity. Now, in the question, they will give you the kinetic energy, they will give you the mass. So you have to sit down and list down the parameters. Take your time and read through the question. You have to take your time and read through the question because you have to know that now in the question, the kinetic energy is given, the mass is given, but there is no any velocity. So you have to make sure that all the parameters is in the question before you start solving. So look at the question on your screen. The kinetic energy of a moving object is 32. If the mass of this object is 4 kilograms, calculate its velocity. So you have to sit down and list down the parameters. Here, the kinetic energy is 32 joule. 32. And we have the mass. The mass is 4 kg. V, we don't know. Now, before you solve this question, you have to know that the SI unit of mass is kilogram. And the SI unit of energy is joule. You have to know all this so that it will guide you to know the parameters well. As soon as you see this unit, it stands for mass, and this unit also stands for kinetic energy. Now we are going to look for the velocity. After listing down the parameters, you first write the formula for kinetic energy. You can just go straight to the point and write down the formula for finding the velocity. But you can also use this equation to solve for your velocity. It's the same thing to solve for your velocity. So if, now let us start. We have the kinetic energy being 32. You write your 32 here. Half times the mass, 4, times V square. V square. So this one is simple. You just write your 32 times 2 is equal to 2 V square. The same thing. You can also use this formula to do it. So here, this one will cancel this. We have 32 times 2, you get 64. Is equal to 4 V square. 4 V square. 4 V square. 4 V square. So here you divide both sides by 4. Divide both sides by 4. This 4 will cancel this 4. So 64. 64 is equal to V square. out of 4 is equal to V squared. So 64 out of 4 will give you 64 out of 4 will give you 64 out of 4 will give you 16. Come. So 64 out of 4, you just write long division method, okay? You just use long division method. So here, you get your 64 here. Then you get your 4 V square. 4 V square out of 4 out of 4. So this one will cancel this. So 64 out of 4 is equal to V square. So here, if you don't know anything about this, you just use your long division method. Long division method, okay. So you write your 64 here. 4 goes to 6 how many times? So you have your 1 here. You have your 1 here. Then you write your 4. Then this you get 2. The next one, bring your 4. Okay? So 4 goes to 24 how many times? You just simple what? Multiplication. Okay. Simple multiplication. 4 times 6 will give you 24. So this times this will give you 24. Then you get your 0 here. So we have 16 is equal to V squared. So 16 is equal to V squared. 16 is equal to V squared. Then here you're not done. You find the square root of both sides. Okay. So this one too, so that this one will cancel this. So we have 4 is equal to V. But if you write 4 here, you're not done. If you write 4 is a figure. This 4 is a figure. So if you write 4 is equal to V, you are wrong. It will mark you wrong. So just 4 meters per second. 4 meters per second is equal to the velocity. So don't forget that the unit of velocity is 4 meters. The unit of velocity is what? Meters per second. So the answer will give you 4 meters per second. 4 meters per second. And let me explain it again. Now, somebody can also use this method. Somebody can also use this method by making V square the subject. So 2 times kg over m out of is equal to what? V square. Somebody can also use this one. So this one is so simple. So you just put in the figures. So we have 2 times So we have 2 times 32 out of 4 is equal to V squared. So here we have 64 out of 4 is equal to V squared. Then here you get your 16 is equal to V squared. Then you find the square root of both sides. So that this will cancel this. You have 4 meters per second square is equal to V. So this is the answer. You can also use this formula. So if you know this one is the most easiest one. So if you know this formula, you just write down the formula and put in the figure. It is also accepted. Just write down the formula and put in the figure. It is also accepted. Now let us go to second example. Let's go to second example concerning kinetic energy. Concerning kinetic energy. So from here, we'll be going to energy transformation. Let us solve another example concerning kinetic energy. Now take this question. Take note of this question. Take note. It is very important. I want you to take note of this question. Now, a body of mass 12.0 kg is placed on an orange tree 20 meters above the ground. I calculate its potential energy with respect to the ground. if the body is released from this height, what will be the kinetic energy just before it hits the ground? G is equal to 10 meters per second square. So this question is very technical question. So if, especially for the if you don't understand the question well, you get it wrong. So I want you to pay attention to what I'm going to write on the board. Now look at the question. Here, the mass of the question is the mass of the question is 12.0. Now, 12.0 is not 120. Now, students always do this mistake. This one is 12.0, it's not 120. So this one is 120. And this one is, we have a point here. So 12.0 is the same as 12. I want you to take note of that. 12.0 is the same as 12. So we have the mass being 12.0 kg. The SI unit, you have to check the SI unit of mass. We have kilogram here, which stands for the mass. So the next one is placed on an orange tree, 20 meters above the ground, which is the height. The height is measured in what? Meters. So the moment you see M there is what? The height. So our height is 20.0 meters, the same as our 20. It's not 200. 20.0 is the same as 20, not 20. So we are told to find the potential energy. And gravity is 10. So gravity is always constant. 10 meters per second square. 10 meters per second square. 10 meters per second square. So before you start solving the question, you write down the parameters. After writing down the parameters, then you write down the formula. So you can see it on your screen. So potential energy is mass times gravity times height. Mass times the gravity times height. So here the mass is 12. And the gravity too is 10 meters per second. And the height is 20. The height is 20. So here, after writing down the formula, you just put in the figures. Put in the figures. So here the mass is 12. So 12, this one will give you 120. 120 times 20. 120 times 20. So don't forget that as soon as you finish, potential energy is measured in what joule. So you just write the final answer there. So here, you just, if you know you cannot do it, just go to the board 120 times 20 like this. If you don't want any trouble, just take your time and do it. Okay, just take your time and do it. So this will give you 0. At the end, you have to get 2,400 joins. So this will give you 0. This one will give you 0. This one will give you 0. You come to, you stand here. This, you write it here. 2, 2, 4, 2, 1, 2. Then you add them. 4. So our final answer, you get 2,400 joule. So this is our final answer. So if you take your time, don't be in a rush, take your time and do it well. Just list down the parameters. After listing down the parameters, you write down the formula, because when they are marking, they will mark this formula. They will mark it. And if you're able to put in the figures, they will also mark it and they will mark the final answer. So it is very important for you to follow the instructions. Don't just go there and write this. If you write 12 times 10 times 20, without writing the formula for potential energy, they will just circle it like this. They will just circle it like this. They will not mark it for you, because this one is very important. The examiner will look for this formula before coming here and the final answer. So writing down the formula is very important, and you put in the figures, then you go. So it is very important. So the final answer will get 2,400 joule. 2,400 joule. 2,400 joule. Now let's go to II. I hope this one you understood what I said. Oh, it is not difficult. Potential energy is mass times the gravity times height. So if you are told to find the potential energy, just write down the formula and put in the figures. And remember that the gravity is always constant, so you have to put that in your head. It's 10 meters per second square. The gravity is 10 meters per second square, so any time a question is given, they can give you the mass and the height without giving you the gravity. You have to know that the gravity is 10 meters per second square. So you have to add it. Now, let's go to RI. Let's go to RI. The RI is very technical. The RI is very technical. Also, if the body is released from the height, what will be the kinetic energy just before it hits the ground? This one, if you don't understand the concept, this concept, you get it wrong. You also write down the formula for kinetic energy, and you get it wrong. Here, the formula for kinetic energy is not important here, or it's not needed. If the body is released from the height, like this one, like this marker, look at the marker I'm holding, like this one. So if I leave this marker, it will just go down. So now, the energy possessed by this marker is the potential energy, because it is what? It is above the ground. So the energy possessed by this marker is potential energy. So if I just release the marker like this, the potential energy will be converted to kinetic energy. Pay attention. I want you to pay attention. This one, the RI is technical. If you don't understand it, you get it wrong. You don't have to write any formula for kinetic energy, because in the question, we don't have any velocity. We don't have a velocity, so take note of that. So look at what I'm doing. Now, I'm holding the marker like this. Now, I'm holding the marker. So if I release the marker, it will just go down. It will just go down. So here, as soon as I release the marker, the potential energy in this possessed by this marker will be converted to kinetic energy. So RI, if the body is released from the height, what will be the kinetic energy just before it hits the ground? So just write your RI, your answer. If the body is released, the potential energy will be converted to kinetic energy. Therefore, the kinetic energy is 2,400 joules. So if the body is released, the potential energy will be converted to kinetic energy. Then you just write, therefore, so if the body is released, the potential energy will be converted to kinetic energy. Therefore, the kinetic energy is 2,400 joules. So this one is simple. This one, there's no calculation involving there's no any formula. You don't waste your time and write down the formula for kinetic energy and put in the figures, because there's no any velocity. So this one is simple. So just write, if the body is released, the potential energy will be converted to kinetic energy. Therefore, the kinetic energy of the body is 2,400 joules. 2,400 joules. So now our next subtopic is the energy transformation. Energy transformation. How one form of energy is being converted or being transferred from one state to the another. From one state to the another. This one too is very important. how energy is being converted or being changed from one form to another. Now, before we start, let me give you some examples concerning energy transformation. Now, let me take you back to your kitchen or any other place. Now, let's go to kitchen. Now, in kitchen, we have gas cooker over there. We have your gas cylinder. Now, the LPG gas, it is known as the liquefied petroleum gas. Now, that gas contains the chemical energy. That gas contains chemical energy. If you want to use the gas to prepare your food, you cannot put the food on the cylinder, but you put it on the gas cooker. Now, the chemical energy in that cylinder will be converted to heat energy. That will help you to prepare your food. The chemical energy in that cylinder, the cylinder contains the chemical energy. So it will be transferred to what? Heat energy. That will help you to prepare your food. Now, another example is charcoal. If you put charcoal in coal pot, the charcoal contains the chemical energy. So if you burn the charcoal, the chemical energy in that charcoal will be converted to heat energy. That will help you to prepare your food. So as soon as you put the saucepan on the coal pot, it will become hot so that you can prepare your food. So the charcoal contains the chemical energy. And the chemical energy, as soon as you burn the charcoal, it will be converted to heat energy so that you can use it to prepare your food. Now, another example is what? Dry cell. It is also known as what? Battery. If it is one, it is cell, and if two or more is battery. Okay, so if you put what? Dry cells in what? A torchlight. The cells contains chemical energy, and the chemical energy will be converted to electrical energy, and the electrical energy too will be converted to light energy. This one too is so simple. So now, but if you are told to write energy transformation of the following, maybe a dry cell, a torchlight, and if you write on the board, if in your book you write chemical energy like this, chemical energy, then you go to electrical energy. Electrical energy, then you go to light energy. You go to light energy. This one is wrong. This is not energy transformation. This procedure is wrong. We normally use an arrow like this. This one is very important. Take note of that. It is very important. Take note of that. Now, so if you are told to state the energy transformation on how a torch gets its light, just write the first one. You put in what? The cells. So the cells contain chemical energy. So you just write chemical energy here. Then you bring your arrow like this, nicely, like this. Then you go to here, you write electrical energy here. So here, as soon as you write this arrow, it means that the chemical energy has been converted to electrical energy. It means that the chemical energy has been converted to electrical energy. Now, the next one, you bring your arrow here. Then you get your light. You get your light energy. You can also add what? Plus heat energy, because always the bulb will become what? Hot. So plus heat energy. So if you are told to define energy transformation in your own term, if you don't have any idea about the definition of energy transformation, you can just define it is a process or is a way in which one form of energy is being transferred to another form of energy. This one is a fair idea. Now, look at the definition of what energy transformation. So, it's the change of energy from one form to another. It's simple. So, if you don't have any idea, you can sit down and think and write down something. So, it refers to the change of energy from one form to another. And I have told you we have different forms of energy, and they are all related to each other. So I have given you a typical example how a torchlight receives its light. So the cells, you put in the cells. So the cells contains the chemical energy here. Here the chemical energy will be converted to electrical energy, and the electrical energy will be also converted to what? Light energy plus heat energy. Then you get it correct. Don't write it in a statement form. You have to bring this arrow. If you also write this one in form of this too, you are wrong. Then you bring your comma here. You write electrical energy. Comma, light energy. This one too is wrong. This one too is wrong. This procedure is not accepted. This one too is wrong. So take note of them. Do it according to what you are told to do. So chemical energy, electrical energy, and light energy plus heat. It is very important. Now, let's go to another example concerning energy transformation. Now, we have the laws of conservation of energy. The laws of conservation of energy. It states that energy can neither be created nor destroyed. It states that energy can neither be created nor destroyed, but can be transformed from one form to the another. And I give you typical example. If you go to kitchen, we have gas cylinder there, we have gas cooker over there. Now, the cylinder contains the gas, and the gas also contains what? We have the chemical energy in the gas. So here, the chemical energy will be converted to what? Heat energy, so that it will help you to prepare your food. Now, another example, I also gave you charcoal. The charcoal also contains chemical energy. So as soon as you burn the charcoal, the chemical energy will be transferred to heat energy, so that it will help you to prepare your food. So that is the energy transformation. That is the laws of what? Energy transformation. It states that energy can neither be created nor destroyed, but it can be transferred from one form to another. It can be transferred from one form to another. From one form to another. So let us write down some examples of energy transformation. Some examples concerning energy transformation. So the most important thing is to remember this arrow. Don't list the energies, the form of energies there, and bring comma. If you bring comma like this, you are wrong. If you list them Ivan, like this too, you are wrong. So you just take your time. If you put dry cell in a torchlight, the first energy transformation is what? The first energy is what? The first energy is chemical energy. Now, some examples of energy transformation is on your screen. Now we have electrical energy can be generated from the mechanical energy of electric generator. Now, how can this happen? Now we have the mechanical energy. That is what the generator, moving part of the generator, provide what? The mechanical energy. Moving part of what the generator provide the mechanical energy. But I want you to take note of something here. Now, the generator is stationary object or machine. So it possesses potential energy. It possesses potential energy. And the moving part also possesses kinetic energy. Now, listen. So here, potential energy plus kinetic energy is equal to mechanical mechanical energy. Potential energy plus kinetic energy is equal to mechanical energy. Take note of that. It's very important. This one, they can ask you in objectives. Okay, so potential energy and mechanical energy, potential energy and kinetic energy come together to form the mechanical energy. So, generator. How can generator produce what? Light. So let us go back to the example. Now, electrical energy can be generated from a mechanical energy of an electric generator. So mechanical energy, the first is what? Mechanical energy. To bracket, moving part of the generator. And I said the generator is what? Stationary. It possesses potential energy, and its moving part also possesses kinetic energy. So if you combine them together, you get your mechanical energy. Then from mechanical energy, the mechanical energy will be converted to electrical energy. To be converted to electrical energy. And after that, it will also be converted to what? Light energy plus heat energy. So always, light energy goes with what? Heat energy. And sound energy also goes with what? Heat energy. I want you to take note of that. Because the bulb or the lamp will become hot. So as soon as the light is on, very soon, it will be hot. So light plus heat energy. Here, you don't write any arrow. You just write the operation sign, addition sign, and then write your heat energy over there. So the first example is what? Electrical energy can be generated from mechanical energy of an electric generator. Here, the mechanical energy will be converted to electrical energy. And the third one, the electrical energy will be converted to light energy plus what? Heat energy. So this one too is simple. Now let's go to example 2. Energy transformation in a torch makes use of dry cell. So this one too, I told you. So this one too is, well, what? Explanatory. So we have the chemical energy. The dry cell contains the chemical energy. Then the chemical energy will be converted to the chemical energy in the dry cell will be also converted to electrical energy. Then you go to light energy plus heat energy. That is the bulb. Now, the third one, a mango fruit falling from a tree or any object falling from a height to the ground. I demonstrated it for you to see, like the marker. So if I leave this marker, this marker possesses what? Potential energy. It possesses potential energy. So if I leave this marker to hit the ground, the potential energy will be converted to kinetic energy. So as soon as it hits the ground, it will make some sound. So sound plus heat energy. So when you can go for mango and other, very soon you'll be searching for mango. Then if you pluck the mango, as soon as it hits the ground, you can see that you can feel some hotness from the fruit. So we have potential energy. Here, as soon as it falls, the potential energy will be converted to kinetic energy. So in the midway, it's both what? Potential and what? Kinetic energy. So then you go to kinetic energy. So as soon as it hits the ground, it will make some noise. It is known as what? Sound energy. Then the sound plus what? Heat. Sound plus heat energy. So now, the fourth example is dissolving calcium carbide in water. Dissolving calcium carbide. So if you go to the welders, they normally use this calcium carbide. Calcium carbide. We know the carbide. So it's calcium carbide. Calcium carbide. So the welders normally call it carbide in the form of white. It is white in nature. So the calcium carbide contains the chemical energy. The calcium carbide here contains the chemical energy. So here, the chemical energy will be converted to what? Heat energy. The chemical energy will be converted to heat energy. Now, we shall meet on Monday. So, we are done with the topic, conversion and conservation of energy. So we shall meet on Monday. Monday, I'm going to treat acid, base, and salt. So get ready. We shall meet on Monday. Thank you for watching, and I hope you are staying in your house. The COVID-19 is a very dangerous disease. So I'm urging you to stay indoors so that you will not get the virus. or you cannot contrast the virus. So stay indoors. Thank you.
Abundant Grace International School, we are located right in Obuasi, precisely BDM. The school has a number of facilities that aid in learning. We have qualified and trained teachers who are ready and willing to assist the children. The school has many facilities such as the ICT laboratory. We also have a science laboratory. We also have a library. The school has a number of buses which convey the children from their various destinations to the school premises. We have the football team, we have the drama group, we have a lot, and the school is based on the Christian principles. For more inquiries, you can call this number 0541 310 901 0541 670772. Abundant Grace, in God we trust.